Hey guys, in this video we're going to talk about Chapter 2, Section 4, Equations for Lines in the Plane. So let's go ahead and do a little bit of a review problem. So we're going to write an equation in slope-intercept form for the line that contains the points -2, 4, and 6, 1. So all we need to define a line is to define a line, we need either A, 2 points, B, a slope, and a point. Okay, because knowing the slope and knowing a point is going to give us another point. So we just need 2 points to define a line, basically. So we have these 2 points, and the first thing we did was we used these 2 points to get the slope. So remember, our slope formula is y2 minus y1 over x2 minus x1. And here we can label this as x1, y1 if we wish. We could have easily labeled it as x2, y2, it doesn't matter. But here's x1, y1, here's x2, y2. So using our formula, just plugging in these values into our formula, we get 1 minus 4 over 6 minus -2. So on top we're going to get -3. On bottom this becomes 6 plus 2, which is 8. So our slope is -3 over 8. And the next thing we need to do is figure out what our y-intercept is. So we can figure that out because we know our generic slope-intercept form is of the form y equals mx plus b. We know a y, we know m, we know x, and now all we need to do is figure out what b is. So you can use either this point or this point as x comma y, it doesn't matter. I'm going to use the first point. I'm going to say, okay, so x is -2 and y is 4. We could have easily said x is 6, y is 1 from this point, but I'm choosing to use the first point. Alright, so we know that. We just figured out what our slope was. It's -3 over 8. So let's put all of this information into this form right here and solve for b. So y is 4. We get y equals m times x plus b. Alright, so simplifying this, we have -3 over 8 times -2 over 1. We can cross simplify, so 2 goes into itself once, 2 goes into 8 4 times. Multiplying straight across, -3 times -1 over 4 times 1 is going to give us 3 over 4. Okay, so that's going to simplify to that. And now all we have to do is subtract 3 over 4 from both sides to figure out what b is. Alright, so you can either put this in Desmos or calculate it by hand. I'm just going to, I'm just going to put it in my calculator here, but anyway, it's as a mixed number, it's going to be, as an improper fraction, it's going to be 13 over 4 is our b value. So our line in slope-intercept form is y equals m, which we found to be -3 over 8, x plus b, which we just found to be 13 over 4. So that's a little review of how to do problems like these. What about this one? So how could we write this in slope-intercept form? What are the values of m and b? So again, slope-intercept form is of the form y equals m times x plus b. So when we're asked to put something in slope-intercept form, we're asked to isolate y. We want to get y on one side by itself. So how do I do that here? How do I approach this? Well, in your previous algebra class, or whenever you saw this last, you probably talked about clearing denominators to make your life easier. And what do I mean by that? Well, I don't want to deal with these fractions, that's for sure. So to get rid of fractions, you can do something called multiplying both sides by the least common multiple. Okay, so to clear fractions, this is just a review. To clear fractions, we can multiply both sides of the equation by the least common multiple. This is abbreviated as LCM. This is our least common multiple. So how do we find it? Well, what's a multiple? So a multiple is basically, you're taking a number and you're multiplying it by 1, you're multiplying it by 2, you're multiplying it by 3, multiplying it by 4. All of those numbers, when you do that multiplication, are multiples. So for example, if we look at 20, okay, that's our first denominator, and I'm considering multiples of 20. Multiples of 20. Well, the first multiple of 20 is 20 times 1. 20 times 1 is 20. The second multiple of 20 is 20 times 2. 20 times 2 is 40. The third multiple is 20 times 3, which is 60, and so forth. And it goes on forever, right? Now, what about 80? What are the multiples of 80? Well, we have 80. 80 times 1 is 80. 80 times 2 is 160, and so forth. Right? Those are the multiples of 80. Now, what's the least multiple that these two sets share? What's the least common multiple of 20 and 80? Well, that's going to be 80, right? Because 80 is a multiple of both 20 and 80, and it's the smallest number that's common to both of them. Okay? So least common multiple is 80. So what we can do is we can multiply both sides by 80 to clear that fraction, those fractions. So right here, when I do 80, and I can do some scratch work over here just to show you guys that it's going to clear, I'm going to do 80 over 1 times x over 20, and these guys are going to cross divide each other right here. So 20 goes into itself once, and it goes into 80 4 times. Multiplying straight across, we simply clear to 4x. Okay, so I'm going to rewrite this. Instead of 80 times x over 20, I'm going to just write it as 4x because of the scratch work here. All right, same thing over here. I'm doing 80 over 1 times y over 80, and these guys clear on the diagonal, right? 80 goes into itself once, it goes into 80 once, multiply straight across to just get y. So this just clears to plus y. So this distribution, this mess, becomes 4x plus y equals, 2 times 80 on this side is 160. And now I can easily get this thing into y equals mx plus b form. So let me go ahead and erase some stuff just to make some room. Okay. So what do I have to do to isolate y, right? We're trying to get y by itself. That's the goal here. So to isolate y on the left side, I can simply subtract 4x from both sides. So that clears to 0. And now I have y equals 160 minus 4x. And if I want to, I can arrange this so that the negative 4x term is first. And so this is my answer. And here m is going to be negative 4. That's the number attached to x. And b is my constant number, which is 160. All right, so let's write a formula for a line that passes through this given point and has the following slopes. So the first one, our slope is 1.87, kind of a weird number, but it's still a number, so we can use our generic formula y equals mx plus b. And what we're going to do is we're going to plug in x, y, and m like we usually do and solve for b. So here we can see x is -1 and y is 2. So 2 equals m, which was given as 1.87, times x, which is -1, plus b, and we'll go ahead and solve for b. So this becomes 2 equals -1.87 plus b, and now I'm just going to go ahead and add 1.87 to both sides to get b by itself. So I get 3.87. Alright, so my answer for part A is going to be y equals 1.87, that's m, times x, plus 3.87, that's b. So that is our answer here in y equals mx plus b form. That's our formula. Okay, let's look at the next one. So this time we're given a slope of 0, and we want to put this in y equals mx plus b form. It's still passing through the same point, by the way. Like, that's the point for all three of these guys. So here we have x equals -1, y equals 2, and this time m is 0, so what's b? Well, again, we're just going to plug in those values into our generic formula up there. So we get y equals m times x plus b. Simplifying on the right, we get 0 plus b when we do that multiplication, and of course 0 plus anything is just whatever that thing is, so 0 plus b is b, so b is equal to 2. Okay. So if we write this in y equals mx plus b form, we can write y equals mx plus 2. Now you're not typically going to see this 0 times x on the streets. You're just going to clear that to 0, right? 0 times anything is 0. So what we're really going to want to write is just y equals 2. Now I want to talk about what this looks like graphically. So this is an important concept that we may have touched on, but I want to hammer it home here. So an important thing to note is that any line that is, or actually let's say it like this, any line that has a slope of 0 is horizontal. And what this means in fancy terms is parallel to the x-axis. Okay, so that's what that means. So if I were to graph this thing, if I were to graph the line y equals 2, all we would do is we would simply go up to y equals 2, that's our y-intercept, and we would plot that point right there. And we can use the slope, rise over run. You know, basically the slope being 0 says we rise 0 and we can run however much we want in any direction. So we're not moving in the y direction. And what this amounts to is just a bunch of infinitely many points on this horizontal line, right? So this is the line. This is the line y equals 0. This is the line y equals 0. You see how it's parallel to the x-axis? It doesn't have a slope, right? Because we're not rising, we're just running to get to the next point. We're just running to get to the next point. We're not going up in the y direction. So yeah, that's it. What about this last part C? Undefined. What does that mean? What does an undefined slope mean? Okay, so let's write this as a little note here. So any line that has a slope which is undefined is vertical. What this means is it's parallel to the y-axis. That's what that means. Okay, so if I were to write an equation for a line that has an undefined slope and it passes through negative 1, 2, so here x is negative 1, y is 2, the way that I would write this is simply x equals 1. That's how I would write that. So anytime you have an undefined slope, it's going to be of the form x equals something. And all that means is that we have a vertical line. It's going to pass through, in this case, x is equal to 1. So we find x equals 1, which is right here. So it's x equals 1. And then we're going to just draw a vertical line through it. This is an undefined slope. There's no run, there's just rise. Okay, so, you know, any other point on this line is not going to have any kind of run from the previous point. We can see that it's parallel to the y-axis, so it's vertical, which means up and down, right? And so these two lines right here are parallel. And what else did I want to say about an undefined slope? That's basically it. But yeah, so for zero slope, we're of the form y equals something. That's for a zero slope. Y equals a number. And then for undefined slope, sometimes we call it no slope. We say x equals something. Alright, so that was that. Let's move on to this example. We want to find the equation of the line intersecting the graph right here at x equals 1 and x equals 8. So remember, to write a line, we just need two things. We need 2 points to be able to graph a line. And the fact that we're given this information, that we have an equation and we know that the line is gonna, we know that 2 points on the line are gonna be hitting this graph at 2 points. So, and the 2 points that the graph is hit at is x equals 1 and x equals 8. You know, we could draw this if we wanted to. We could put it in Desmos. If I were to put this thing in Desmos as just the equation, it would look something like this. Let's see. Well, let's see. This is going to be maybe right here. I don't know. Maybe it looks something like this if you were to put it in Desmos. So it says, okay, so here's our equation of this graph that we're given, x squared minus 2x plus 3, and we want to find the line that hits it at x equals 1 and x equals 8. So perhaps this is x equals 1, and perhaps up here we have x equals 8. And there's a line that exists that passes through these 2 points, right? That's what we're trying to figure out. We're trying to find the equation of this line that passes through these 2 points. Well, all that's missing is the y value for those 2 points. If we can find the y value, then we have 2 points that defines a line. So how do we find the y value? Well, we're given this equation. We're saying, oh, well, these 2 points lie on this equation. So if I plug in the corresponding x's, I should get a y. So for x equals 1, I can say, okay, well, for x equals 1, I have y equals 1 squared minus 2 times 1 plus 3. I'm just evaluating this function at x equals 1 to get the corresponding y value. When I do that, I get y equals 1 minus 2 plus 3. And so that's going to be y equals 2. So when x is 1, y equals 2, bam, that is a point on our line, right? So this is the point 1, 2, this little guy right here, this red this first red point. Maybe I'll do it in red. This is 1, 2. Okay. Now for the other point, we do the same thing. We say, okay, well, for this other point up here, x is equal to 8, and I want to figure out what that corresponding y value is. So I'm just going to sub in 8 into that function rule to figure out what it is. So I get y equals 8 squared minus 2 times 8 plus 3. So I get y equals 64 minus 16 plus 3. Alright, so I'm getting 3, right? Let's see, 64 minus 16. No, I'm not getting that. I was like, that's not right. 64 minus 16 plus 3. Okay, so I'm actually getting 51 here. So when x is 8, y is 51, so that is another point on my line. So that's all we need for a line. We need 2 points, and we can write the equation at this point in time because we use our slope formula and get a slope, and then we figure out what b is using one of these x, y values. All right, so again, we're trying to write this in y equals mx plus b form. Let's go ahead and find b. So, find m. So m is going to be y2 minus y1 over x2 minus x1, second point minus first point. And I can call, if I want, I can call this one x1, y1, this one x2, y2. And so when I plug everything in my formula, I get y2 is 51 minus 2 over 8 minus 1. And so this is going to give me 49 over 7, which is 7. Okay, so cool. M is equal to 7. Check. We got that. Now all we need to do is pick an x comma y. I'm going to pick this one for x, y. So I'm going to say my first point is x equals 1, y equals 2. I know now that m equals 7. And let's solve for b by putting this in the generic equation up here. So we have y equals m times x plus b. And let's solve for b. So we get 2 equals 7 plus b, subtract 7 from both sides to get b equals negative 5. Alright, so we have everything we need. We have m and b. So our equation of our line is y equals 7x minus 5. That is our final answer here. So if we were to put this in Desmos along with this equation, we would see that they do indeed intersect at these 2 points, x equals 1 and x equals 8. So if you want to, you should try this. You should just put this equation Desmos, and then in the second line put this equation y equals 7x minus 5 and see that they cross. Okay, so let's talk about parallel lines. So in the last video, we talked about that we mentioned that parallel lines don't have a solution, right? They don't cross. That's what that means graphically. They don't cross. Algebraically, what does this mean? Well, it means that they have the same slope or the same steepness. However, the y-intercepts can be different. So I have an example here that I used Desmos with. So basically, I just graphed these 4 lines in Desmos, and we can see that all of these lines have the same slope of negative 3 over 2, right? That's the number attached to x. But all of the y-intercepts are different, and that's okay. So these are parallel lines. They're never going to cross. They don't have a solution. They have the same slope. So let's do some practice finding equations of parallel lines. So this first problem says find an equation of a line which has a y-intercept of negative 3 and is parallel to the line y equals 6 minus 1. So we're trying to figure out the equation of a line that's first of all parallel to this. What does that tell you about the slope? Well, it tells you the slope needs to be the same as this one, right? We're trying to find another line that has this same slope. That's what parallel means. So the slope needs to be 6, right? They're parallel, so the slope needs to be the same. And the y-intercept is going to be -3. And so the line that I'm interested in is y equals mx plus b, and that's my answer here. So this is a line that is indeed parallel to this line. They have the same slope, and it does have a y-intercept of -3. So that's the equation there. Let's try another one. We want to write an equation in slope-intercept form, so y equals mx plus b, for the line that passes through this point and is parallel to this line. Now we need to figure out what the slope of this line is. That's our first step, because parallel lines have the same slope. So let's go ahead and manipulate this guy. We're trying to figure out the slope so that we can find out b for this new line. Right? So we start with this. We're trying to figure out the slope because parallel lines mean they have the same slope. So if I isolate y, I'm going to first do that by subtracting 3x from both sides, giving me 10 times y equals 20 minus 3x. And now I'm going to divide everybody by 10 to get y alone. So I get y equals 20 divided by 10 is 2, minus 3 over 10, that can't be simplified, x. Alright, so what was the point of doing this? I'm trying to find the slope, because this mysterious line that I'm trying to find must have the same slope as this because it's parallel to it. So what's the slope of this? Well, the slope we can see, because it's in slope-intercept form, is -3 over 10. So we know that our new line, our line that we're actually interested in, we really don't care much about this. We just wanted to get its slope. We know that the line that we're interested in has a slope of -3 over 10, and it passes through 0, 2. Now, if you want, you can just look at this and say, oh, well, that's the y-intercept, because that's where x is 0. So this is b equals 2. Or you can do the trick that we do, which is we say, okay, well, x is 0, y is 2, let's solve for b. Let's solve for b by using this generic form up here. So let's do that. So we have y equals m times x plus b. Well, this is nice because anything times 0 is just 0. So 2 is equal to b, as we just mentioned. So b is equal to 2. And so our equation is y equals m times x plus 2. And that is our answer here. So this line is parallel to this line. That's true. And it passes through this point right here. Because if you were to plug in x equals 0, y equals 2, you would get a true equation. Let's try another one. So we want to write an equation in slope-intercept form for the line that passes through this point, and it's parallel to this line that's defined by these points. So again, this is the line that we're interested in. I'm highlighting it in green. And in yellow, that's the line that we need to figure out the slope for, because once we have a slope and once we have a point, we have a line. Okay? So let's figure out the slope of the line that we don't really care about too much. So, for this one, you can say, okay, well, this could be x1, y1, this could be x2, y2, and so the slope, m, is going to be y2 minus y1 over x2 minus x1. These negatives become positives, so we get -3 plus 7 over 1 plus 5. That's going to give us 4 over 6, which if we simplified by 2 is going to give us 2 over 3. So the slope is 2 over 3, and so that's good news for this green line. So we know that the slope is also going to be 2 over 3 because the green line is parallel to the yellow line. And the yellow line has a slope of 2 over 3. Parallel means same slope. So the line that we're interested in has a slope of 2 over 3, and it passes through this point up here. So we know that x is 6 and y is negative 4. So let's go ahead and use that information to solve for b. So our generic equation is y equals mx plus b. Plugging in y is negative 4, m is 2 over 3, and x is 6, we can easily solve for b. So 2 over 3 times 6, we can think of this as 6 over 1, and we can think of the 3 and the 6 cross-dividing each other. So 3 goes into itself once, it goes into 6 twice. Multiply straight across to get 2 times 2 is 4 over 1. So we get negative 4 equals 4 plus b, and then I can subtract 4 from both sides to get b by itself. So b is equal to negative 8. Awesome. Now we have everything we need. We have b, and we also have m, so let's go ahead and write our equation. So our equation is going to be y equals m x plus b, and that is our final answer here. This equation is parallel to this line. It's parallel to this line. Even though we didn't find the equation of the line, all that's relevant is the slope of that line. Parallel lines have the same slope. So it's parallel to this line for sure because they have the same slope of 2 over 3, and it passes through 6 comma negative 4. If you were to plug in x is 6, y is negative 4, you would get a true equation. That's what it means. It passes through that point. Okay, so what about here? Are the lines parallel? Well, all we care about is, do they have the same slope? That's what that means. Do they have the same slope? Or m? That's all that means. So let's go ahead and rearrange these guys so that we are in slope-intercept form, and then we can easily identify if they have the same slope. So for the guy on the left, I have y plus 3 equals negative 2 times 3x plus 6. And I'm going to use the distributive property on the right first before I start moving stuff. Negative 2 times 3x is going to give us a negative 6x, and a negative 2 times a positive 6 is going to give us a negative 12. We still have y plus 3 on the left. Last thing to do is to subtract 3 on both sides to isolate that y so that I'm in y equals mx plus b form. And I get y equals negative 6x. These two combine to make negative 15. So this is my line in y equals mx plus b form. So all that's relevant is the slope, so let's circle it. Parallel lines have the same slope. Now let's check out this one. So all we have to do here, there's no distributing to do on the right. All we have to do here is isolate y. So divide both sides by 2. And I get y equals, well, negative 12 divided by 2 is negative 6x plus 1 over 2. This is my line in y equals mx plus b form. And we can see that the slope is also negative 6. So since they have the same slopes, they are parallel. That's the only way you can tell, is that if they have the same slopes. There's no other way. It makes it pretty straightforward. Okay. Okay, so we want to find the equation of the line that goes through this point, and is parallel to the x-axis. Okay, what does that mean? Parallel to the x-axis. Well, the x-axis is this horizontal axis right here, and parallel to the x-axis means that it's a horizontal line. So that means that it has a slope of 0. Parallel to the x-axis means the slope is 0. It's just a flat horizontal line. So that's easy. We know that the slope is 0. And we know that it goes through the point x is -3, y is 1. So in y equals mx plus b form, we're going to have y equals 0 times x plus b. Solving for b, we get b equals 1. Okay, so it's actually going to be not this line right here, but it's going to go through y equals 1, so it's going to be this line right here. So this line is parallel to the x-axis, and it passes through this point -3, 1. That's going to be somewhere right here. So this is -3, 1, if you can see that. Now, what if I changed this and said, what if it's parallel to the y-axis? Let's change the problem a little bit and say it's parallel to the y-axis. What does that mean? Well, what that means is that the slope is undefined, and it's going to be a vertical line. So let me go ahead and draw it. So it's going to look like this. This is going to be our line. And this time the slope is not 0. Here, the slope is undefined. And when the slope is undefined, that means we have x equals something. Well, what is that something? Well, it has to be the x that was given to us. We have x is -3, y is 1. So our answer here is x equals, well, the x that's given is -3. So that is going to be the line that's parallel to the y-axis that passes through -3, 1. It has an undefined slope. This is the equation of that line right there. X equals -3. All right, give an equation for the line parallel to y equals 60 minus 5x, and it passes through root 2, pi. Yeah, those are some weird numbers, but it's okay. We treat them just the same like we would any other numbers in an ordered pair. No problem. So first of all, parallel means same slope. That's what that means. Whenever you see parallel, you should think same slope. That's it. No more complicated than that. So this line that we're interested has the same slope as this line. So what's the slope of this line? Well, it's going to be -5, right? That's a number attached to x. So the slope of our new line is going to be -5. We know that it passes through this point right here. So in the x spot is root 2. In the y spot is pi, which is a number. And so we can use y equals mx plus b to figure out what b is. So y is pi, so I'll replace y with pi. So we have pi equals m, which is -5, times x, which is root 2, plus b. Now, when I multiply -5 times root 2, it's simply -5 root 2 just squished together like that. That's all that is. And then if I want to get b by itself, I can add 5 root 2 to both sides. And yeah, b is a strange looking number. It's pi plus 5 root 2. But it's a number nonetheless. So b is going to be pi plus 5 root 2. And now I can write my equation. So my answer here is going to be y. So, okay. So y equals mx plus b. So y is pi. So we have pi equals, oh, sorry. We already found b. Never mind. Our answer here is going to be y equals m x plus b. B is this whole mess. It's okay. No worries. It's still a number. All right, there's our equation. All right, now let's talk about another special type of line. So perpendicular lines, okay? They do have a solution they're going to meet. And what does this mean graphically? Well, it means that perpendicular lines are going to cross at a right angle, all right? They're going to meet at a 90-degree angle. And algebraically, perpendicular lines have what we call opposite reciprocal slopes, and I'm going to get into what that means in a second. But yeah, if you look at this picture right here, you know, these lines are going to meet at 90-degree angles. Typically, we'll use this little box to represent 90 degrees. And that, you know, that's the definition of perpendicular lines. So now let's talk about what opposite reciprocal is before we start doing problems with perpendicular lines. Opposite reciprocal basically means you flip it, so the numerator and denominator flip, and then you change the sign. So if the sign's positive, you change it to negative. If the sign is negative, you change it to positive. Okay? So for example, 3 over 4, we're going to first flip it. That's the reciprocal part. And then we're going to make it opposite by adding a negative. Because it was positive initially, we'll change it to negative. Okay? Negative 6 over 5. Flip it. That's the reciprocal. Make it positive because we're switching from negative to positive. Okay, that's the opposite part. Okay, what about 2? Well, 2 is understood to be over 1, right? That's the understood, you know, that's how we understand 2. So if we flip it, we get 1 over 2. If we make it opposite, it's negative now because it started out as positive. All right, what about 0? Flip 0. Well, 0 is understood to just be under a number. Who cares what number it is? Maybe it's understood to be over 1. We can think about it like that. If we flip it, we get 1 over 0, which is not a thing in math. We don't divide by 0 here. And so, basically, whenever you see 0 in the denominator, you're going to say, okay, well, this is undefined. Like, we don't even want to go there. So if 0 is in the denominator when you flip it, undefined. Negative 9. It's understood to be over 1, right? Any number by itself is understood to be over 1. So flip it, 1 over 9, change the negative to positive. That's the opposite reciprocal. Root 5. That's understood to be over 1. Flip it, 1 over root 5, change the sign to negative since it was originally positive. So that's what I mean by opposite reciprocals, okay? So let's do some practice here. We're going to find an equation of the line that has a y-intercept of 2 and is perpendicular to this line. So perpendicular means opposite reciprocal slopes. So originally my slope is 7, so the opposite reciprocal of 7, well, we flip 7, that's 1 over 7, make it negative. So our slope of the line is negative 1 over 7. And it has a y-intercept of 2. So b is going to be 2, and therefore, the equation of my line is going to be y equals m, which is negative 1 over 7, x plus 2. And that is my answer here. Okay, let's try this one. So we're going to find the equation of the line that passes through this point and is perpendicular to this line. Perpendicular means opposite reciprocal slopes. So we take a look at this slope. M is negative 1 over 2. We flip it to 2 over 1 and make it positive. Because it was originally negative, we make it positive. So 2 over 1 is 2. That's my slope. Alright, so M is 2. It passes through x equals 1, y equals 2. And now we can use this info to figure out our y-intercept. So y equals m times x plus b. We're just going to sub in all of these values here and solve for b. So we have y equals m times x plus b. Okay, solving for b, we get 2 equals 2 plus b. Let's go ahead and subtract 2 from both sides to get b equals 0. So our line is going to be y equals m, which was 2, x plus 0. We don't have to write the plus 0 though. So this line that I boxed in red is our answer. Okay, that's the equation of the line that passes through this point. So true equation, when we plug in x is 1, y is 2, we get a true equation. And it goes through that graphically, that line graphically. And it makes a right angle with this line right here. So if you were to plot these two lines on the plane, they would meet at 90-degree angles. We could sketch it. You could put these in Desmos if you want to. Y equals 2x is going to look something like this. And then negative 1/2 x plus 8 is going to look something... that's not good enough. Let's see. Well, the point is that they meet at 90-degree angles. So this one is going to be y equals negative 1/2 x plus 8. And you can see that they meet at that 90-degree angle right there. Perpendicular lines. All right, let's try this one. So write an equation in slope-intercept form for the line that passes through this point, and it's perpendicular, okay? Perpendicular means opposite reciprocal slopes to this line right here. So it's not obvious right away what the slope of this line is, so let's go ahead and put him into slope-intercept form so that we can find the opposite reciprocal. So to put him in slope-intercept form, I need to isolate y. So the first thing I'm going to do is I'm going to add 8x to both sides. It's going to give me 4y equals 40 plus 8x. I'll now divide both sides by 4 to get y alone. And so I get y equals 40 over 4 is 10, plus 8 over 4 is 2, so it's 10 plus 2x. So what is my slope? Well, remember, this line that I'm concerned with is perpendicular to this line that I just found in slope-intercept form. So the slope of the perpendicular line, and sometimes I use this symbol to represent perpendicular, this little like upside down T. It's perpendicular. So the slope of the perpendicular line, if I take the opposite reciprocal of this, 2 over 1, it's 1 over 2, make it negative. Okay, that's the slope there. It passes through negative 10, x is negative 10, y is 4. So let's go ahead and figure out what b is from this info, and we'll have our answer. This is not our answer. We just needed to find this so that we could find the slope, so that we could find the line that we're interested in, that slope. Okay, so let's find b. So we have y equals m times x plus b. So y is equal to m, negative 1/2, times x is negative 10 plus b. And let's go ahead and solve for b. So over here, negative 1/2 times 10 is 10 over 2, which is 5. So this is 5 plus b equals 4. And I'm going to subtract 5 from both sides to give me b equals negative 1. Perfect. So we know what our slope is up here. It's negative 1/2. We know what b is. So our answer is y equals negative 1/2 x plus 1, or plus negative 1, which is negative 1. So this is our answer. So this line is perpendicular to the line that was given, and it is going to pass through negative 10, 4. Okay, let's find a possible equation for the line that is perpendicular to the graph of 2x minus 8 equals 3 if the two lines intersect at x equals 20. Then we want to find the x and y intercept for each line. Okay, so we have two lines that we're dealing with. Let's find the equation of each line. So this is going to be line 1, and I'll put line 2 over here in purple. This is line 2. So line 1, we're already given the equation for it. That's nice. So the equation of line 1 is 2x minus 8y equals 3. And as usual, we want to put this thing in slope-intercept form so that we can easily identify the slope, okay? So putting this in slope-intercept form means isolating y. So I'll first subtract 2x from both sides to get the y term by itself. When I do that, I get negative 8y is equal to 3 minus 2x. And now I can just divide everybody by negative 8 to get that y term by itself. Okay, so I get y is equal to, well, 3 over negative 8 is simply negative 3 over 8. I can just move that negative to the top. A negative 2 divided by a negative 8. A negative divided by a negative is a positive, and 2 over 8 simplifies to 1 over 4. Okay, so this is the equation of line 1. So this is the equation of line 1. Now, the equation of line 2. Line 2 was said to be perpendicular to line 1. Okay, it's said to be perpendicular to that. So what does that mean? That means opposite reciprocal slopes. Okay, so opposite reciprocal slopes. So the slope of line 1 is 1 over 4. If I flip it, it's 4 over 1, and then put an opposite sign, it's negative. Okay, so we have a slope for line 2. So that's our first clue. All right, so we're almost there for line 2. Now, what do we need to determine the equation of the line? We need a point and a slope, or we need 2 points. We have a slope. How can we find a point that lies on line 2? Well, we're given this clue that the two lines cross each other at x equals 20. So they have the same value for x and y when x is 20. Well, I know what y is going to be when x is 20 based on the equation for line 1. Y is going to be negative 3 over 8 plus 1 over 4 times 20. Now, if I simplify this, 1 over 4 times 20 is 5, right? 20 divided by 4 is 5, so we get y equals negative 3 over 8 plus 5. I can just put this in the calculator. I'm getting 37 over 8. So that's all we need. That was the clue. The clue was that both of these lines share the point x equals 20, y equals 37 over 8. Okay, that's where these lines meet. That's where they intersect. They have the same x and y values at that point. So for line 2, we have a slope, we have a point. Let's go ahead and find b. So b, we have y equals mx plus b. We know y is 37 over 8. M is negative 4. X is 20. We're trying to find b. Okay? So negative 20 times 4 is negative 80. So we have negative 80 plus b is equal to 37 over 8. And let's go ahead and add 80 to both sides. And I'm just going to put this in the calculator. 37 over 8 plus 80. I'm getting 677 over 8. Not a beautiful number. Well, maybe it is, but anyway, that's our b value. So the equation for line 2, again, is based on m and b. So the equation for line 2 is going to be y equals m, which is negative 4x, plus 677 over 8. That is our equation for line 2. And everything else I'm just going to erase so we have some more room to answer our next questions. So, line 1 and line 2 are perpendicular. Why are they perpendicular? Because the slopes are opposite reciprocals of each other. That's why they're perpendicular, and that's the only reason that they're perpendicular. They also meet each other at x equals 20. Y equals, what was it? I can't remember. But anyway, they meet at x equals 20, and they have the same x and y value there, okay? So we have the two equations, line 1, line 2. Now let's answer this last part that says find the x and y intercept for each line. So the y-intercept is easy because it's just b. So b for line 2 is 677 over 8. And b for line 1 is negative 3 over 8. That's our constant number there. Now, what about the x-intercept? Well, the y-intercept occurs when x is 0. The x-intercept occurs when y is 0. So we set y equal to 0 in our equation up here and solve for x to find our x-intercept. So we have 0 equals negative 4x plus 677 over 8, and we're just going to solve for x. So I can subtract 677 over 8 from both sides. And if I divide both sides by negative 4, I'm just going to put this in the calculator to give me, let's see, okay, as a fraction, I'm getting 677 over 32 is my x-intercept. Okay, so that's my x-intercept. This is my y-intercept. All right, so we can do the same thing for the green line, line 1. To find the x-intercept, we set y equal to 0. So taking this equation, we're putting 0 in for y. We get 0 equals negative 3 over 8 plus 1 over 4x. And we're just going to solve for x. Now I'm going to do the little trick to clear the fractions. I'm going to multiply both sides by the least common multiple of 4 and 8, which is 8. Okay, so if I distribute that 8 in there, negative 3 over 8 times 8 clears the fraction to just give me negative 3. 8 times 1 over 4x clears the fraction. 8 divided by 4 is 2, so this is going to give me plus 2x. And then I can solve for x. So I can add 3 to both sides. So I get 3 is equal to 2x, and then I'll divide both sides by 2 to get my x-intercept of 3 over 2. So my x-intercept is 3 over 2. My y-intercept is negative 3 over 8. So the y-intercept, again, and just this is recall, y-intercept is where the graph crosses the y-axis. So it makes sense that the x-intercept is where the graph crosses the x-axis. Okay, so that's a little side note. And you guys should put this equation in Desmos, and you should put this equation in Desmos and verify that the x and the y-intercepts are what we said that they are. Alright guys, that's the end of this video. Thanks for watching. I'll see you guys next time.